audible now?
Yes, ma'am.
Yes, ma'am.
Okay. So now third generation computers were built on the integrated ICs. Okay, so now integrated ICs are nothing but you have multiple or thousands of circuits integrated on a single chip there. Okay, that was the replacement that took place during the third generation over here. And because of the usage of these ICs inside the system, the size of the system were drastically reduced there. And mini computers were having the better computational time compared to the previous two generation systems over there. So previous two generation computers took a lot of time to give you the results, but that was overcome by this particular system that was generated in the during the third generation over here. The maintenance cost was low compared to the previously two system that we have deployed there. Okay, so because replacing a single transistor may be easier for us, but we really don't know how many transistors were gone wrong or damaged over there, or how many vacuum tubes were lost there or damaged there. So looking into those concepts, the maintenance of the IC, okay, so maintenance of IC became very easy for the end users there or the programmers there. That's why we said that the maintenance cost of this particular third generation system was good compared to the previous two generation systems. And these things were usually trying to give the general or serve the general purpose concepts or the general purpose things that usually the end user was expecting. Okay, so these things can be used for the commercial purpose also in those days. Okay, because whenever we develop any new kind of stuffs, so we always look into the generation, that is revenue generation kind of stuffs. So that's why they thought, is it possible for us to use these kind of systems that are generated can be used for the commercial purpose or what? Okay, so this made at least closer to the usage of this system towards the commercial applications over here. Next, in the fourth generation, so we have very good ICs that were developed, we people can say, because we are moving towards the microcomputer rather than the mini computers. So whenever we say microcomputers, please remember we are trying to deploy almost all kind of controlling unit on a single ICs. Okay, so there we have, ICs there were developed in the last generation only, but these were doing different tasks. But we wanted all these things to be done by a single IC. Okay, that's what we came across the microprocessor. So it was controlling the memory, it was trying to control the input-output device. Along with this, we'll be using some supporting ICs, but main task will be done by this particular ICs itself. So we call it as a controlling unit. So controlling power was given to a single IC. Okay, so please remember that's why microprocessor came into existence. Okay, the expansion of this, the depth knowledge of this you may get in the upper semesters, maybe in the fourth semesters. Okay, we have subjects called as microprocessors or embedded systems there that you'll be studying. There you'll be studying the in-depth, or you'll be getting the in-depth knowledge of these all things. Okay, then these systems, if you look at these systems, the size is drastically again changed over here compared to the previous generation systems, because now single IC is capable of doing multiple ICs task over here. Okay, so this was the duty of the microprocessor that replaced, okay, multiple ICs over there. And the price, if you look at the price of these things, okay, these were become very cheaper compared to the previous generation computers over there. Okay, and we call it as personal. We started calling it as a personal computers because it can be offered by any, persons for their general purpose uses there. Again, ICs, that is memory ICs, came into existence during this era, that is during the fourth generation. Okay, so not only we are there, in those days we used to use the magnetic tapes for those purposes. Then those magnetic tapes, along with those magnetic tapes, we come across some of the memory ICs that helps to speed up the system. Okay, so that's what we call it as the random access memory, or the RAM memories that which were found on the ICs came into existence just to boost the system, or to get the working faster from these kind of systems. Okay, so that was deployed or used in the fourth generation systems. Okay, and this can be used as a part of the networking. That is also made possible with the help of this system. Okay, so this became, if I take this as one simple network over here, so this particular, if I take this system, this became one of the terminal of the network system there. Okay, so this was a best thing that was contributed by the manufacturers during the fourth generation. Okay, so if you look at LSI, VLSI, these are nothing but the large scale integration, very large scale integration, ultra large scale integration. Means you are trying to deploy, okay, a large number of, 10,000s of circuits on a single IC. That's what is the meaning of this LSI, VLSI, okay, and ultra LSI technologies. Okay, so this is about the fourth generation systems. So then you have the final generation systems, which we people are, maybe we are using or may not be we are using, okay, but maximum people are using these things. Okay, so now if you look at these things, the storage capacity is very high in this case, okay, because the storage has, the size of the storage has become drastically changed. Okay, it became very, very small. Very small memories are able to store huge data there. So that made possible, and because of that, the size of the system is drastically changed over there. Okay, and these were started acting as a terminal of the system. This was found in the fourth generation, but little advancement in the system made it as to become a part of the network technology itself. And we people can rely on this, and these are affordable. Very faster there, and these were become the part of the what we call it as the supercomputers there. So students, am I audible? Students?
Yes, ma'am.
Yes, ma'am.
Okay. Any disturbance is there, please interrupt. Computers, okay, supercomputers there. And please remember, not only that, then we went for what we call it as a parallel processing also. So what is the meaning of parallel processing? We wanted to do look at the things there. Okay, so if you look at the things there, if you go ahead with the previous generation computer there, this processes where are the what we call it as the inputs are given in the serial fashion. This is the first task that is assigned for the system. Then after completion of this task, this was given for the execution, and this was after the completion of the second task, this task was given for the execution, and so on. Okay, and this was taken care by this system itself. We are not bothered about all those things because we deployed what we call it as a microprocessor there. So it used to do all those things along with the help of some of the softwares there. So what software was helping to do these things, we'll be studying those things in the under the heading of the software. We'll not worry about that right now, but the tasks were done serially in those days. Okay, but we wanted to work the things done in a parallel manner. Okay, so now I wanted all the tasks to be done in the same time. Okay, so now I'll be giving these three inputs, means I expect the output of all these three things at the same time. So that's what we call it as a parallel processing. Okay, so now this was made possible during the present era. That's what we call it as a fifth generation system. And this is a part of what we call it as a supercomputers. So it's very costly nowadays, and you might, I'll be talking about that also. It's very costly process. That what we people are talking about in this case. Okay, and this is capable of working on the newer softwares, something like the artificial intelligence. Okay, so because, and if you look at artificial intelligence is going to do some of the specific tasks over there. If I quote some of the examples for that, okay, so now voice recognition is one of the artificial intelligence task there. Okay, so self-driving car. So what is the meaning of that? It is going to do a specific task over there. Okay, okay, Alexa is one of the thing that has came into existence. It recognizes our voice, and depending on whatever commands you are giving, so it is going to act according to that. Right? You heard about Alexa, no? Hello?
Yes, ma'am.
Okay, so
Yes,
similar to
ma'am.
that, Okay, so similar to that, the self-driving car. So if you sit on the system in a car there, so automatically if you set the source and the destination from where you are starting, your journey has started, and where you are going to end there, if you set that, so it automatically selects a path and it will make you people to reach the destination, and there is no hurdle because it is taken care by the system there. If humans are there, they make some mistakes there to take you people to the destination there. When it is given to the system there, we can give a guarantee that so it is going to take you to the destination without any accidents that is going to happen in between there. Okay, so because maximum times it is taken care by the whole system that you have deployed using the artificial intelligence inside the automobile system there. Okay, so these are the things that are presently emerging in the 5th generation systems. So these are specific to the work specific systems that we people are presently working on, and we usually call these as embedded systems. Okay, so if I take simple example for you all, mobiles. Okay, what mobile is able to do? So initially it was doing only the calling and receiving of the calls and sending the messages. Now we started usage of some of the applications can be deployed on that. You started working on the WhatsApp, then you started deploying the emails on that particular mobiles now. Okay, now you people can able to work on the word processes on the your mobiles. All these things. Okay, you started making usage of that. You are making it as a general purpose one. But initially the designing of a mobile was only for calling purpose and receiving the call purpose. But nowadays it has become a general purpose system there. Okay, that is what is the meaning of the the embedded systems there. Is that clear to everybody, students? So these are variety of generation computers that we people can think of. Any doubt regarding the generation of the systems? Hello? Hello? Hello, students. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
So now
ma'am.
any doubt regarding the generation of the systems there? Any doubts regarding the generation of the systems there?
No, ma'am.
No doubts. Okay. So we'll go ahead with the next bit called as the computer types. You have a variety of computer types that you people can play with. The first one is supercomputers. So what is this supercomputer? Supercomputer is too costly and it is huge in size, and these things are purely meant for, okay, so what we call it as the scientific purposes. Okay, these are most powerful systems and able to play on huge data. How much data you are able to give, and that to real-time data it is able to work. So if you look at the real-time data, so huge data is generated at any given instant of a time. If I take simple example here, you play with the social medias, correct? You play with the WhatsApp, you play with the Facebook, you play with the Twitter there. So if you look at the data that is generated by those kind of social medias, it's daily. If you look at, I'm talking about daily basis. Hundreds of terabytes of data will be generated per day. Okay, so look at the data that is generated. So if you are interested to play with the data that is generated by these kind of social medias, okay, then normal systems will not help you to do that. Okay, so we need a special kind of computers. That is what is the because of that this super computers came into existence. These are very powerful systems, and the processing of this is very high, and these are very expensive systems. Okay, and these are mainly used for the military purposes, scientific purposes, weather forecasting purposes. Okay, and because these are going to play with, I already mentioned, huge data, very huge data. And at any given instant of a time, 1,000 end users can be connected to this particular super users. Okay, so at any given instant of a time, maximum 1,000 users can be connected to this. Okay, so now if you look at the speed of this, it is capable of executing trillions of instructions in 1 second. So I'll repeat my statement, trillions of instructions in 1 second. That's the power of this particular supercomputer. And Param was the first supercomputer that was developed by Indians. There are many more supercomputers that are existing. Maybe Cray 1, Cray 2 are the computers that are generated by some other, what we call it as the people, not Indians, by other country people. Okay, maybe US country people, maybe maybe the Japanese have deployed or developed the supercomputers there. Right? Then we have something called as the mainframes. Okay, because this at least we already know the usage of this. Okay, so people cannot afford this. Okay, so then we thought of going ahead with the mainframes. So these mainframes are usually meant for what we call it as the organization purposes. That too a bigger organization section rather than the smaller scale organization system, because you have a variety of organizations that you people can have for the bigger organizations, where the organization is deployed in a variety of, various countries, not in a single country. If you look at the size of this is smaller compared to the what we call it as the super computers over here, but these are purely meant for the bigger organizations, okay, larger organizations. These are purely containing the servers over here, and at any given instant of a time, nearly 50,000 users can be connected to this particular what we call it as mainframe computers or the mainframe servers over here. Okay, so whenever we connect our 50,000 terminals are connected, you can have a variety of terminals. Normal PC can be used as a terminal, or usually what they will they'll think of going ahead with the dumb terminals rather than going ahead with the what we call it as the PCs or the personal computers there. So what are these dumb terminals? Dumb terminals are having only the keyboards along with one simple rack, okay, which is helping us to connect that particular system to the mainframe there. And you have only the monitor and only one simple rack, thin client, we call it as a thin client, which does not have any processing capacity there. Okay, please remember, I'm talking about a thin client which cannot do anything. Dumb terminal, it's a dumb terminal, it's not capable of doing anything. So whenever this system is connected to this mainframe servers there, it is putting a request to this particular server here. Server is granting the things back to the client here, okay, this particular terminal here, and whatever input you are interested to again provide there, whatever changes you wanted to make in that file, you make that, again you dump that back to the server there. Okay, so any processing, any storage that takes place at the mainframe servers, not at the terminal side. This is what is the meaning of dumb terminal. So I'm not saying that you can use only the dumb terminal. So instead of dumb terminal, you people can go ahead with what we call it as the intelligent systems also. That is PC, personal computers also. Okay, personal computers also part of this. So in this personal computers, you have the processing unit also, and you have the memory also. You have the storage capacity for this system also. So this can be connected to the mainframe there. Okay, so the meaning of this is some of the operations can be processed at the client side rather than everything doing at the server side here. So that was the main motto behind connecting the intelligent system to the as a client to the system there. Okay, so now depending on our requirements, the clients were changing there. Or the terminals that we are going to connect to the mainframes are changing. You don't want to do anything at the terminal side, then use the dumb terminal. But if you want something to be done at the terminal side there, then use the intelligent system instead of a dumb terminal as the end user there. So now please remember, the number of terminals that you people can connect to this mainframe is minimum 50,000. Okay, and again this is little larger in size. Okay, and it is capable of working in parallel. Okay, how this main supercomputer was doing, in the similar fashion, this is also capable of working in parallel. Okay, so now it supports the parallel processing over here. Right, so this is all about the mainframe computers. Then you have the mini computers. So in the mini computers, so these were usually meant for smaller organizations. Again, you have the server that is deployed, and you people can connect the end systems. Usually these terminals are the dummy terminals rather than the dumb terminals rather than the intelligence terminals over here. Okay, so now these are connected to these this particular mini computers over here. These are usually used, I already mentioned, for the small scale industries rather than the bigger organizations over here. Right, so this is very much similar to that of the mainframe computers, but these are smaller in size. Okay, these are very smaller in size and the work that you people can expect out of it is little lesser compared to the mainframe computers, because its cost is lesser compared to the mainframe computers over here. The number of terminals that you people can connect for this is less compared to the number of terminals that we people can connect to this. Okay, so now you have something called as IBM has developed a AS400, and if you look at the mainframe there, okay, so now IBM has developed AS391 as the mainframe computer there. So variety of mainframe computers were already existing in today's world. So similar kind of mini computers are also existing in the today's world. Okay, so now as an end user, okay, because we cannot offer for the, because we are not a person, and we people are not the part of the organization also, we are not the part of the military, people are the researcher over here. Okay, so then what we'll think of going ahead with the independent machines over there. Okay, so now you know that microcomputers are the powerful computers that are working with a greater speed, which are really needed for the end users, or which are capable of meeting the end users requirements over here. And if you look at these things, these are laptop systems, because we want the system or the size of the system to be very, very small. Okay, because I want the system to sit on my lap or maybe on my palm there. Okay, these are my needs. Okay, we have the tabs that are presently we people can go ahead with. All are the part of the micro computers there, because we are trying to deploy a particular chip which is having almost all the controls inside that single chip there. Okay, so many chips are replaced by single chip in this case. Because of that, the size of that is drastically changed. So this is what is the meaning of this particular a microcomputer, and these are the variety of microcomputers, and these are very, very cheap devices that are available present days. Okay, these are very, so this can be offered available in affordable price. Okay, starting from 15,000. Okay, so you can, it's left to you people. So which company laptop, which company desktop you wanted to purchase. So depending on that, the cost is going to vary. But from 15,000, lesser than 15,000 also. So these PCs are these microcomputers are available nowadays. And this is going to give you the or serve the end user purpose. And these are purely meant for the general purpose work. Okay, and now what we people are thinking of, we don't want these computers, because always we cannot carry these systems along with us. Okay, even carrying a laptop has become tedious kind of stuff for us. So what we people have done, we thought of going ahead with what we call it as the embedded system. We people are nowadays working with the embedded systems and the smartphones. And I cannot, okay, so you already know about the smartphones. So even though I don't mention about the smartphones, you are well versed with the smartphones there. Okay, there is no issue about that. But if you go ahead with the embedded system here, okay, so now it's going to do a specific task, as I already mentioned. Whatever task you are going to assign for that, only it is going to do that task. If you are telling it to do the monitor, the pacemaker that is installed in the heart of the, near to the heart of the.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so now look at this. So this is again the expansion of the same computer hardware there, where we went for the generation of the computers. Now we'll look into the block diagram. I'll not go in depth of these things. Okay, so but I'll give an overview, because we'll be dealing with all individual parts in the upcoming slides over there. So this is your computer there. So what it consists of? It consists of a central processing unit, and it is consisting of what we call it as the output unit and the input unit here. Okay, so we'll be studying about the input devices also. We'll study about the output devices also. And in this class, we'll be talking about the memory here. So before that, I'll say a few words about this particular block diagram before we proceed with the memory. Okay, so now please remember, you have the input device. From input device, you are going to give the input to the system here. Okay, so please remember, the input is coming from this to this particular central processing unit. Okay, so the data is moving from input device towards the CPU. The reverse direction flow, flow of data is not possible in this case. It's a unidirectional flow of data. Input has to flow from input device to the CPU device. Okay, you cannot expect anything to flow back from the CPU back to the input device. It's not possible. It's only unidirectional flow of data. Input has to come from the input device towards the CPU there. So if you look at the output device, the data has to move from, okay, so these directions are mattering a lot for us. Okay, the data has to move from the central processing unit to the output device. So I cannot get any data from output device back to the central processing unit there. I hope I am making it clear to everybody. Okay, so this is very important fact that I am talking to you all. So in this case, input has to move from input device to the central processing unit. Output has to move from the central processing unit towards the output device. So nothing or no flow of data from output back to CPU or from CPU back to input device. Okay. Then, so whenever data is entering into this particular central processing unit, and you know that this central processing unit is going to take care of the processing of the data that has given from the input device. Okay, so now before it processes, work on any of the data, please remember it is going to dump that data inside the memory. Okay, so you can compare this with the, okay, so our human mind there. So even we have our, even our human brain is also having the processing in it, okay, control in it, which controls all the input and output devices of that, okay, because we have hands, we have, okay, what we call it as eyes, nose, everything. So all these things are controlled with the help of the brain. If our brain is not working, the whole system is going to collapse. We people are in the coma. Okay, I hope I'm making it clear. This is very important fact that I'm talking, because every time we compare this system with the human body there, or human being there. Okay, so whatever brain is doing, the same kind of task will be done by the central processing unit also. It is acting as the brain of the system there. Okay, and if you give the power supply to this, because to operate this, we need to give the power supply. That power supply is acting as the heartbeat for this particular system. Okay, because to work the brain, okay, even if you look at the human being there, if you want your brain to work properly, okay, your heartbeat should be running there. If your heartbeat is not working there, then you people are we people are dead there. Correct, no? Are we dead person if heartbeat is not there? Yes or no? Hello?
Yes, ma'am.
Yes. Okay. The same thing is true with this also. So we have to provide the power supply. So once you give the power supply, then only it's going to activate the brain. Otherwise, no activation of the brain. Okay. So now this central processing unit is going to act as a brain of the system. Okay. And for that, how we people are able to store the data? Okay. We have the memory. In our brain also, we have a short-term memory and long-term memory. Okay, so short-term memory, so in that short-term memory, so the data, whatever you are going to store, it will be stored for a limited amount of time. Okay, so after some time, it will be erased. Similarly, for this system also, we have the short-term memory and a long-term memory. So in short, this is usually the brain usually talks with only the short-term memory, not with the long-term memory. Okay, so whatever I am saying with the human being, the same thing is true with the system also. Okay, so this control unit or this brain of the system is going to talk with only the short-term memory, not with the long-term memory. Okay, so now beyond this, we have one more memory. That memory we usually called it as a long-term memory or the secondary memory. Okay, this memory is again divided into two parts. We'll be studying that in the later classes. But just remember, so to which memory this usually this control unit talks is the short-term memory. We call it as the volatile memory. Okay, that is random access memory. Is that clear to everybody? Hello students, is that clear?
Yes, ma'am.
Okay, so now
Yes,
with
ma'am.
this, okay, so now we'll conclude our today's session, because in the next class I'll be talking about the memories. Okay, so I said computer memory is different from the secondary memory. We'll be talking about the computer memory and the